Science. As we have seen from the continuity equation of incompressible flow, that the product of area into velocity is constant. So that means inlet area into inlet velocity is equal to outlet area into outlet velocity. And this means that area and velocity are inversely proportional to each other. So this implies that if area increases, then velocity will decrease. So is it possible that if area increases, then velocity also increases? The answer is yes. So let's see how it happens. So here comes the concept of compressible flow, Mach number, and etc. So let's have a quick recap of our concepts. So if the density of the fluid changes with respect to time or space, then it is called compressible flow. So what is Mach number? The ratio of the velocity of fluid flow to that of the velocity of sound in that medium is called Mach number. So let's have some categorization. If Mach number is less than 1, then it is called subsonic flow. If Mach number is equal to 1, then it is sonic flow. If Mach number is greater than 1, then it is supersonic flow. We have another type of categorization, and that is if Mach number is less than 0.3, then it is incompressible flow. Similarly, if Mach number is greater than 0.3, then we have compressible flow. So for compressible isentropic flow, isentropic is nothing else but reversible adiabatic process. So for compressible isentropic flow, we have this equation dA by A is equal to m square minus 1 dV by V, where A stands for area of cross section, m stands for Mach number, and V stands for velocity of fluid. So dA represents the change in area, that is exit area minus inlet area, and similarly dV represents the change in velocity, that is exit velocity minus inlet velocity. So let the area be increased from inlet to exit, that is exit area is greater than inlet area, so dA is positive as we can see from the image. So we have various cases. In case 1, let's take the Mach number of fluid to be less than 0.3. So in this case, the fluid will behave as incompressible and subsonic, as we have seen from our categorization. So as we have assumed that dA is positive, and m square minus 1 here will be less than 0 because our m is less than 0.3. So for LHS to be greater than 0, dV should be negative because then only negative and negative will become positive. And dV negative means exit velocity is less than inlet velocity. So here we have velocity decreases in the direction of flow. That means if area is increasing, then velocity is decreasing. We have another case, that is case 2. So in this case, Mach number is lying between 0.3 and 1. So fluid will behave as compressible and subsonic. As from our assumption, dA is positive. Again here, m square minus 1 will be less than 0. So the same mathematics will go on and we'll find that velocity decreases in the direction of flow. So again we have area is increasing but velocity is decreasing, similar to the previous case. Now we have third case. Here, Mach number is greater than 1. So the fluid is behaving as compressible and supersonic. So from our assumption, dA is greater than 0. But in this case, m square minus 1 will be positive. Why? Because m is greater than 1. So for LHS to be positive, dV should be positive because then only positive and positive will become positive. So dV positive means exit velocity is greater than inlet velocity. And this means velocity increases in the direction of flow. So here we have, if area is increasing, then velocity is also increasing. Isn't it interesting? So does it mean that our concept is a scrap? A big no. Area increases, then velocity decreases if the flow is incompressible and subsonic. Area increases and velocity increases if and only if the fluid is compressible and supersonic. So thank you for being with us.